Hi everybody, welcome back to another of my lessons. I'm Mrs. John and today I'm going to be talking to you about conservation of mechanical energy. So in the last lesson I'd explained the meaning of the word conservation. So to conserve means to keep, not to lose, to have it all together. It's the same before and after. And what does the word mechanical energy mean? I haven't told you what that means. Now, mechanical energy usually stands for kinetic energy or gravitational potential energy or elastic potential energy. It can be any of these ones. Okay, and so I'll just give you an example of what does this mean, conservation of mechanical energy. So suppose you have a ball and you throw it up and then it goes all the way up and it falls down. So the moment it leaves your hand when you throw it, that's when it's got the maximum speed. So let's say it's got 20 joules of kinetic energy. At all points, provided no energy is lost in any other forms, at all times the total energy will be 20 joules. Okay, so when it goes from the bottom and it reaches the top, it no longer has any kinetic energy because it's no longer going anywhere any higher, but all the energy will be gravitational potential energy and it will have 20 joules of gravitational potential energy. And then when it falls down, the whole time the energy will be 20 joules, but when it reaches the bottom, all that gravitational potential energy will be converted to 20 joules of kinetic energy. Okay, so that's what this is. Now, here's another example. Let's say you have a catapult. Okay, the catapult is like a slingshot. So it's kind of like this. You hold it, it's got Y, and it's got like a piece of elastic which you have to really stretch back, and then you could have a piece of something, a ball or a stone or a pebble or something, and you pull it and it goes. And let's say you're shooting something up vertically up into the air. Okay, now because this is an elastic, something that can be stretched, you stretch it as much as you can, so the energy that that elastic has is all elastic potential energy. And let's say it's got 50 joules of elastic potential energy. The moment this pebble leaves this elastic and it goes up into the air, all this 50 joules of elastic potential energy is going to be converted to 50 joules of kinetic energy. And then when it reaches the highest point in its flight, all that 50 joules of kinetic energy will become 50 joules of gravitational potential energy. And then when it falls down, all that gravitational potential energy is going to get converted to kinetic. So the point I'm trying to make here is that this number stays the same, only the form of the energy changes. So based on that knowledge, let us solve a couple of questions that you have in this work, in this booklet of yours. So this is on conservation of mechanical energy. I'll just do a couple of questions and then I will work through them and take a photo and upload it for you to check your working. So I'm going to do question 1 and maybe question 5. Okay, so question 1 is a ball of mass 0.52 kilograms. I'm just going to write the mass of the ball, is thrown up from the ground up to someone who's standing on a ledge. Now our g is always 10 meters per second squared. The ledge is 10 meters high. Okay, that's the height of the ledge. So someone's standing a ball, thrown it up. Now A is use EP is equal to mg delta h to calculate the gravitational potential energy. So your mass is 0.52, g is 10 and h is 10. So that gives you 52 joules. Okay, that's your gravitational potential energy. Then part B is use gravitational potential energy gained is the same as the kinetic energy lost to state the kinetic energy of the ball as it left the thrower's hand. So whatever energy this is gained, it's because it's been changed from kinetic energy. And the way that we write this is EP lost equals EK gained. EP stands for gravitational potential energy. Ek stands for kinetic, and it's the same number. There's no calculation that you have to do here, okay, because you've already calculated the energy. And the last part was use Ek equals half mv squared to calculate the speed of the ball as it left the thrower's hand. So, you know, that's the kinetic energy. Okay, and the formula for kinetic energy is half mv squared, and the answer to half mv squared is 52. So this means your half you can write as 0.5 times your mass is 0.52 times v squared equals 52, or half of that is 0.26. V squared equals 52, or your V squared is 52 divided by 0.26, and you're going to get an answer. So if I just go 52 divided by 0.26, I get 200, okay, and then I just go square root of 200, so this is 200, and so V is square root of 200, you get probably 14.1 is, yeah. So square root of 200 is 14.1 meters per second. So that's the speed with which the ball left the hand. Okay, so that's how you do that question. And then I might just make another little video of question 5 because that's just a bit longer. So I'll stop this one for now and then I'll just make another one. So bye for now.